In this center tap full wave rectifier, during positive half cycle, what happens? Terminal A of secondary of transformer becomes positive, point C at center becomes negative, and B terminal becomes negative, and center T terminals becomes positive. So what we see, diode D1 is connected to positive terminal, anode of diode D1 is connected to positive terminal, whereas anode of diode D2 is connected to negative terminal to the point B. So diode D1 is forward biased and diode D2 is reverse biased. So we see the output is passing through the load resistor is from point A D1 and then RL to point C. In the lower half of the circuit, as the diode D2 is reverse biased during positive half cycle, so no output is through diode D2 which is produced in RL. So we say output is there, and that is due to the upper circuit that is flowing through the current flowing through the diode D1. Now when negative, we consider the negative half cycle at the input. At that time, at the secondary of the transformer, point A becomes negative, point B becomes positive, and because of that we say diode D1 is reverse biased, whereas diode now in this case diode D2 is forward biased. So due to the diode D2, the current flows through the load resistor and not due to the diode D1. So during negative half cycle, what the output we get at the load resistor RL is due to diode D2. So in this center tap full wave rectifier, we get the output due to diode D1 during positive half cycle, and we get output during negative half cycle also due to diode D2. That's why we get the pulsating DC output during both the input cycles, positive and negative. Now we'll go to the third type, that is bridge wave rectifier. Now in this bridge wave rectifier, we can see the diode, 4 diodes are used. In this case we can say diode D1, D2, D3, D4 are connected in a bridge. Now in this case no center tap transformer is used, only step down transformer is used. Even though in the figure you find the number of secondaries are just looking similar to the primary winding, but we have to say always in the bridge rectifier also the transformer used is step down. Okay, so in this case what happens, if you see the input and output waveform during positive half cycle, at the bridge if we say the point A, B, C, D, point A and C, point A becomes positive and whereas point C becomes negative during positive half cycle. So that's why we say diode D1 conducts and diode D3 conducts, and we get the output. During negative half cycle, what happens? Point A becomes negative, point C becomes positive, and that's why now the output waveform across load RL is due to diode D2 and D4. And again during positive half cycle, the output will be there due to diode D1 and D3, and this cycle continues. And we say in the bridge wave rectifier there is a output during positive half cycle as well as during negative half cycle, but during positive half cycle output is due to 2 diodes D1 and D3. During negative half cycle output is there due to D2 and D4. So this is what us just say about the different types of rectifiers and their working in the circuit. Now we will have a look to the comparison between these 3 rectifiers. There are title like property, half wave rectifier, and 2 subtypes of a full wave rectifier, that is center tap full wave rectifier and bridge type rectifier. Now the parameters we are going to see, I will read it in a column 1, that is number of diodes used in these 3 rectifiers, secondary voltage of the transformer, then waveforms seen at the output of the load resistor, then DC output of the different rectifiers, then ripple factor values, then rectification efficiency and transformer utilization. We'll see first parameter, that is Number of diodes used. In half-wave rectifier, we have seen there is only one diode used. In center tap, there are 2 diodes used. In bridge rectifier, there are 4 diodes used. In secondary, second point, that is secondary voltage at the transformer, there is Vm. In the center tap full wave rectifier, the transformer used is a center tap transformer, so we get secondary voltage at the secondary of the transformer is 2 Vm, and in the bridge is simple Vm. Half waveform you can see as shown in the table. So during only positive half cycle we find output. In the center tap we find output during positive and negative, both the input signals, and same in the bridge. DC output in half wave rectifier is Vm by pi. Center tap full wave rectifier DC output is 2 Vm by pi, and bridge rectifier, in a bridge rectifier DC output is given by 2 Vm by pi. Ripple factor for half wave rectifier is 1.21. For center tap full wave rectifier is 0.482, and for bridge rectifier is same as 0.482. The value for rectification efficiency in half wave rectifier is 40.6%. In center tap it is increased, that is 81.2%, and in bridge type full wave rectifier the rectification efficiency is 81.2, means the amount of input AC applied that is rectified and made available at the output, that is rectification efficiency. Transformer utilization factor TUF, it is very small in half wave rectifier 0.287. In center tap it is somewhat more 0.692, and it is more in bridge rectifier, that is 0.811. So this is what end of our video regarding types of rectifiers. So I thank you for all listening the video. Please comment your feedback on this video lecture on our group as well as on our Google Classroom, that is BELIS2I 2019 and 20. Thank you very much. Keep watching the new videos in future.